Welcome back. Today we will learn how to insert a node at the beginning of a doubly linked list. Let us define the structure of each node. We have already introduced about the structure of node in a doubly linked list. So we have int x as a data pod, we have a PREV pointer, and we also have a next pointer, right? So you have the structure like this. Now we define three pointers, that is a start, temp, and mnew. Now this is just a brush up to your memory. The start pointer actually holds the address of the first node. The mnew pointer holds the address of the new node to be created and to be inserted. And the temp pointer holds the address of a node whenever you want to do some operation to a node, such as visit the data, or you update the data in the node, or just move over the entire list. So for these kind of operations, you need the help of the temp pointer. Now I should mention here that in this specific case of adding a node in the beginning of a doubly linked list, the temp pointer will not be required. Okay? So you may omit this definition of this variable temp. Got it? Okay. So you write int user pose. This is a variable. You want to ask to the user about the position where the new node is to be inserted. And of course, in this specific case, we will have user pose equal to 1, right? Now you take start and mnew, both of them to null, and it will be looking like this. Next, you write this message that you ask the user the position where the node is to be inserted, and then you write this mnew to point to the memory allocated dynamically by the help of the malloc function, and you take the data pod, that is mnew arrow x equal to 16, and you also make the pointers PREV pointer and the next pointer to null. So it will be looking like this. This 102 has been taken randomly because these kind of addresses actually is taken care of by the operating system. So for example, this newly created node has been allocated to 102, and that is our assumption. Okay. So the null will be replaced with 102, and it will start pointing to the new node here. Next, this is a check that if store is null, that means there is no node in the list. And if store is not null, then there is at least one node in the list. So if store is null, then this node at 102 will be the first node, right? So * should point to 102. isn't it? So you write start equal to mnew. So whenever you write start equal to mnew, this null pointer will be replaced with 102 and it will start pointing to 102. So the newly created node is the first node, and of course it is the only node in this doubly linked list. Now suppose you have these 4 nodes in your list. Okay, now you have this mnew is pointing to this 102 and this new node is ready to be inserted in the first position of this list. Then what should we do? We write start PREV equal to mnew. Why? Because if you want this node to be the first node, then this node will be the second node, this will be the third, this will be the fourth, and this will be the fifth, right? So if this is the second node and this is the first node, then of course this start PREV, that means this pointer will be pointing to this 102, right? So this null has been replaced with 102 and the null pointer vanishes and it starts pointing to the node at 102. That means the PREV pointer of this node at 743 is now pointing to the node at 102. Clear? Now, since this is a doubly linked list, then this node at 102 will also point to the node at 743, right? So you write mnew next equal to start. That means this one is the mnew next. Now it is null. It should be replaced with 743. And when you write 743, that is the address of this node. So this null pointer vanishes and it starts pointing to this. So you see that the start is still pointing to the node at 743, which is actually the second node now. But it should point to the node at 102 here, because this node at 102 is the first node now. So you write start equal to mnew. So as soon as you write start equal to mnew, this 743 will be replaced with 102 and this link breaks and this link is established. So you can see that start is pointing to the node at 102. 102's PREV is null. 102's next is 743. That means this one. And 743's PREV is 102. That means this one. Is it all right? So let us clean up a little bit and let us see how it looks like finally. Right? So you see that the first node is having a PREV null and the next pointer at 743. Now the node at 743 is having PREV pointer at 102. Clear? So I hope it's clear to you how a doubly linked list works. And in the next video, we will learn how to insert a node at a given position in a doubly linked list. Thank you for watching and take care.